an example of a question on the unit vector. I made this question up. P is the vector 1824. A, you must find the magnitude of P. B, you must find the unit vector in the direction of the vector P. Here, this is a vector. If you have an x-axis and the y-axis, we're looking at this situation of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Then we go up to 24. 1, 2, 3, 4, and so on up to 24. It would be a position vector. That position vector would start at the origin, as always, as usual, and it would go to the end. The end of that vector would be above 18 along the x-axis and beside 24 on the y-axis. So this is the vector that we're looking at. We must find the magnitude of P. Let us see how this goes. If you form a right-angled triangle, you would have x, the horizontal side, and the vertical side. The horizontal side would be 18 units long. The vertical side would be 24 units. Now, this is how it would be. Now, the graph looks, or the vector diagram looks clearly that it is not drawn to scale, but it is just a matter of showing the meanings of 18 and 24. Now, to make it more to the ratios of the lengths of the side, we will redraw it without the x and the y axes. Here, it may look somewhat like this. You have your horizontal side, you have your vertical side. You see that? Nice. Vertical side is 18 units long. Horizontal side is 24 units long. Now, here, you must find the magnitude of P. P is this vector. The magnitude will be the length. So we're using Pythagoras theorem to find it. You remember your Pythagoras theorem, don't you? P squared, the hypotenuse squared is equal to 18 squared, one of the sides squared, plus 24 squared, the next side squared. So therefore, p squared equal, what is 18 squared? 18 squared. Let me put it in basic mode. 18 squared is equal to 324. 324 plus 24 squared. 24 squared equals 576. 576. When you add these together, what do you get? 576 plus 324, 900. So this is 900. Now p squared is 900. You see that? Now p would therefore be the square root of 900. P is equal to 30 units. So that is the magnitude of P. You see that. Now part B. You must find the unit vector in the direction of P. Remember now, the unit vector is going to be a vector looking like this in the same direction as P, but the magnitude is 1. The unit vector, let us call it U and put the symbol over it to show that it is the unit vector. It is generally written as A, comma, B. You already know the magnitude is 1. It's to find A and B now. If this is 1, the magnitude is 1, then unit vector is going to be each of these numbers over 30, because if you have the magnitude 30 divided by 30, you get 1. This is 30 long divided by 30, you get the length of the unit vector equal 1. You already know that the unit vector is 1 unit long. It's now to find the length of this. In this case, this is A, and this is B. You see that? Now, here, the unit vector is going to be 18 divided by 30. Then, comma, you have 24 divided by 30. Let's test it and see. What is 18 divided by 30? 18 over 30 equals 0.6. 0.6, comma. 24 divided by 30. 24 divided by 30 equals 0.8. 0.8. So that would be the unit vector. Let us see what is happening here in terms of the unit vector. This is 0.6, this is 0.8. So this should be 1. So, is it really? This is the unit vector. Let's find the magnitude. The length or the magnitude, sometimes called the modulus, is represented by two vertical lines around the letter that represents the vector. U would be this squared, would be 0.6 squared plus 0.8 squared. So the unit vector, the magnitude, would be the square root of 0.6 squared plus 0.8 squared. You see that? Equals 0.6 squared equals 0.36. 0.36 plus 0.8 squared. 0.8 squared equals 0.64. 0.64. The square root of all this. So it's the square root of. We must add 0.36 to 0.64 now. 0.36 plus 0.64 equals 1. It's the square root of 1. So the magnitude of the unit vector is 1. That proves, just shows that that is indeed the unit vector. So 0.6 comma 0.8 is that unit vector.